Tonight, we are going to talk about something that sounds simple but quietly controls everything. It shapes your past. It decides your future. It bends light. It slows clocks. It makes gravity possible. And yet, even today, we still do not truly know what it is. Spacetime. You hear this word often. Scientists say it casually. Movies use it like magic. Teachers explain it with drawings. But once you move past the surface, once you stop repeating definitions and start asking real questions, something strange appears. We use space-time every single day. Your phone depends on it. Your GPS would fail without it. Satellites are corrected for it. Atomic clocks shift because of it. We have watched it bend around black holes. We have detected ripples moving through it. We have even photographed its effects at the edge of darkness. And yet, we do not truly know what space-time is. We know how it behaves. We know how to measure it. We know how to use it. But the deeper truth is unsettling. We do not know what it is made of. To understand why this is one of the greatest mysteries in science, we must go back to a time when nobody was looking for space-time at all. A time when the universe felt simple, solid, and predictable. For centuries, humans believed space and time were fixed. Space was a quiet, empty stage where events happened. Time was a straight river, flowing the same for everyone. A second in one place was the same second everywhere else. A meter here was the same meter anywhere in the universe. This idea felt natural. It felt obvious, and it worked. It worked so well that Newton built his entire system of physics on it. In Newton's world, gravity was a force that reached across space instantly. The sun pulled the earth pulled the moon. Everything obeyed invisible strings of attraction. Time flowed evenly. Space stayed still. The universe was like a great machine. Then in 1905, a quiet young man sitting at a desk changed everything. Albert Einstein did not work at a university. He did not have a laboratory. He did not lead a research group. He worked in a small patent office in Switzerland, checking designs for machines all day and thinking about physics at night. He asked a question that sounded simple. What would happen if you chased a beam of light? At that time, everyone believed speeds added together. If you ran forward and threw a ball, the ball moved faster than if you stood still and threw it. That made sense. That matched daily life. That is how the world worked. But light did not behave this way. No matter how fast you moved, light always travelled at the same speed. Not almost the same. Exactly the same. This one fact shattered everything. Because if light never changes speed, then something else must change to allow that to happen. Einstein's answer was shocking. Space must change. Time must change. If you move very fast, time slows down for you. If you move very fast, distances shrink along your direction of motion. Time and space are not fixed. They stretch and bend depending on how you move. This was not an illusion. This was not perception. This was real. Time itself was flexible. Suddenly there was no single now for the universe. Two people moving at different speeds would disagree on what moment was happening at a distant place. Past, present, and future were no longer universal. Reality itself fractured into viewpoints. This was the first crack in the old picture of space and time. But Einstein was not finished yet. His first theory handled motion. It did not handle gravity, and gravity was a problem. Newton's gravity worked instantly. If the sun vanished, the Earth would feel it immediately. But Einstein had just shown that nothing can travel faster than light. No signal, no force, no information. So how could gravity act across empty space with no delay? This contradiction bothered Einstein deeply. Then in 1907, he had an idea that he later called the happiest thought of his life. He imagined a man falling off a roof. As the man falls, he feels weightless. If he drops an object, it floats beside him. From his point of view, there is no gravity at all, Now imagine that same feeling inside a spaceship far from any stars, floating freely, no weight, no pull. Einstein realized something radical. Free fall and no gravity feel exactly the same, and standing still on the ground feels exactly like being inside a rocket that is speeding upward. This meant that gravity and acceleration are not different things, they are the same thing. This single idea blew the final door open. If motion can bend time and space, and gravity is just a form of motion, then gravity must also bend time and space. This was the birth of spacetime. Not space, not time, but a single combined fabric. Einstein spent nearly 10 years struggling with the math that could describe this new reality. It nearly broke him. He worked endlessly. He made mistakes. He corrected them. He learned advanced mathematics from friends. He doubted himself. He returned again. In 1915, he finally succeeded. Gravity was no longer a force pulling objects together. Gravity was the bending of spacetime itself. Mass and energy warp spacetime. Objects move along the curved paths created by that bending. Planets do not orbit because they are pulled. They orbit because they follow the straightest possible paths through curved spacetime. Earth is not being tugged by the sun. Earth is sliding along a curved path created by the sun's mass. The universe was no longer a machine with forces pulling across empty space. It was a flexible fabric where geometry itself determined motion. This idea sounded beautiful, but it also sounded impossible. How could space bend? How could time stretch? How could empty nothing have shape? Yet the equations worked. They predicted things nobody had seen before. They predicted that light would bend near massive objects. This was tested during a solar eclipse in 1919. The stars shifted exactly as Einstein predicted. Overnight, he became the most famous scientist in the world. They predicted black holes. They predicted the expansion of the universe. They predicted gravitational waves. 100 years later, we have seen all of these. Space-time was not just a clever idea, it was real. And yet, the deeper we looked into it, the stranger it became. Einstein's equations worked beautifully, but they also predicted places where they destroyed themselves. They predicted singularities, points where space-time curves infinitely, where the math breaks, where time and space stop making sense, at the center of black holes, at the beginning of the universe. Einstein believed these were signs that his theory was incomplete. He thought nature would never allow such madness. But nature did not agree. Black holes are now observed everywhere. They sit at the centers of galaxies. They merge, they collide, they ripple space-time itself. Space-time is not calm, it shakes. In 2015, we directly detected those shakes. Gravitational waves passed through Earth from colliding black holes over 1 billion light-years away. Our planet stretched and squeezed by less than the width of a proton. And our machines felt it. Space-time had spoken. We had touched the fabric of reality itself. And still, we do not know what it is. We can measure its bending. We can detect its vibrations. We can use it to navigate cities. We can use it to scan the universe. But when we ask the deepest question, what is space-time made of? Silence. Is it smooth or made of tiny pieces? Is it continuous or digital? Does it exist on its own or only because matter exists? Did it begin with the universe? Or did something exist before it? We do not know. This is not a small mystery. This is the foundation of everything we know. Because every event happens in space-time. Every light ray travels through it. Every thought you have occurs inside it. Space-time is not just part of the universe. It is the stage of existence itself. And we do not understand the stage. This is why spacetime is one of the deepest unsolved mysteries in physics. We use it, we depend on it, we measure it, but we do not understand what it truly is. And now, the true journey begins. Because once spacetime is born, it does something even stranger. It begins to ripple. Tonight, we go deeper into spacetime, not as a word, not as an idea, but as something real. Something that bends, something that moves, something that controls how the universe behaves, even when nothing seems to be happening. To understand how spacetime bends, we must forget everything that feels normal about space. We must forget straight lines, we must forget flat floors, we must forget that distance is just distance and time is just time. Because in Einstein's universe, distance and time are not fixed. They stretch, they twist, they curve. Imagine a thin rubber sheet stretched tight. Now place a heavy ball in the middle. The sheet sinks. It bends. If you roll a smaller ball near the heavy one, it curves toward it. Not because the heavy ball pulled it with a force, but because the surface itself is bent. That is what mass does to space-time. The sun bends space-time. The earth bends space-time. You bend space-time. Everything that has mass presses into this invisible fabric. But here is the strange part. That rubber sheet example is only a shadow of the truth. In real space-time, it is not just space that bends. Time bends too. And time bending is even stranger than space bending. Clocks do not tick the same everywhere. A clock on the ground ticks more slowly than a clock in space. This is not theory. It has been measured again and again. GPS satellites must correct for this difference every second. If they did not, your phone would place you kilometers away from where you really are. This means your location depends on space-time. Gravity does not only pull your body, it slows your time. On a mountain, time moves a little faster than at sea level. Inside strong gravity, time drags. Near black holes, time almost stops. This means time is not one flowing river. It is a landscape. High places in gravity are fast time. Deep places in gravity are slow time. Two people standing at different heights on the same planet are aging at slightly different speeds right now. Space-time is not the same for everyone. Now think about motion. When you move very fast, time slows down for you. This is not because your body changes. It is because space-time changes. Your path through time shortens as your path through space grows. Motion bends time. Gravity bends time. Space-time is sensitive to movement and mass. Now here is something even more unsettling. Light does not curve because gravity pulls on it. Light has no mass. It curves because space-time itself is curved. Light simply follows the shape laid out before it. This is why stars appear in the wrong place during eclipses. Their light bends around the sun. We see where the star was, not where it truly is now. Space-time lies to your eyes, and it does so perfectly. Now imagine a simple empty universe. No stars, no planets, no matter at all. Just space-time. Would it exist, or does space-time only exist because something is inside it? This question has no clear answer. Some scientists believe space-time is a thing on its own. Others believe it only comes into being when matter exists. We do not know which is right. We do not even know if space-time is smooth. It might be grainy, like pixels. At extremely small scales, space-time may be broken into tiny units. If that is true, then reality itself has a resolution limit. There may be a smallest possible distance, a smallest possible moment. Below that, space-time might not exist at all, and we do not yet have proof. Now think about black holes again. Inside a black hole, space-time bends endlessly inward. Time and space swap roles. All directions lead forward. There is no path back. This is not because of force, it is because the geometry itself has collapsed. Space-time becomes a trap. And at the very centre, Where equations explode into infinity, we reach the edge of knowledge. A place where space-time itself breaks. This is where Einstein's theory stops working, and something deeper must replace it. Now remember, gravitational waves. When two black holes collide, space-time does not stay still. It ripples. Those ripples move across the universe. They stretch and squeeze planets as they pass. Even now, space-time is vibrating silently through your body from distant cosmic events you will never see. Space-time is not a silent stage, it is alive with motion. Now comes the most important truth of all. Everything that ever happened in space-time. Every starbirth, every supernova, every planet formation, every thought you have ever had, every memory you carry. All of it is written into this invisible fabric. Space-time is not background, it is the main character. And yet, we still do not know what it truly is. Is space-time made of energy? Is it made of information? Is it made of something even deeper than matter? We cannot answer. Now imagine removing space-time. What would the universe become? No place for things to be. No moments for things to happen. Without space-time, even existence becomes meaningless. This is why physicists say space-time is not inside the universe. The universe is inside space-time. And that leads to the strange question that keeps scientists awake at night. Did space-time begin with the Big Bang? Or did space-time already exist before it? If it began, then something had to create it. If it existed before, then time existed before time. And that breaks language itself. Now, feel the discomfort of that idea. Your mind cannot imagine a beginning without time. It cannot imagine time without space-time. And yet the universe demands that one of those impossible things is true. We do not know which. Now stop for a moment. You are sitting inside a mystery far deeper than space. You are sitting inside time itself. You are moving through a fabric that bends, stretches, slows and ripples, and you feel none of it. That is how complete the illusion is. Space-time allows reality to move. Space-time allows memory to exist. Space-time allows cause and effect, and yet it reveals none of its secrets easily. Now the next question becomes unavoidable. If space-time bends, if space-time ripples, if space-time traps light and time inside black holes, then is space-time truly fundamental? Or is it built from something even deeper? That is where the next part will take us. Now we reach the most uncomfortable truth of all. We use space-time to describe everything. We trust it to explain gravity, motion, light, and the shape of the universe. And yet, when we ask the most basic question about it, science falls silent. What is space-time actually made of? We know what stars are made of. We know what atoms are. We know what light is. We even know what empty space contains at the quantum level. But space-time itself sits in a strange position. It is not matter. It is not energy. It is not a force. And yet, everything depends on it. Space-time acts like a real physical thing. It can stretch, it can bend, it can ripple, it can be ripped apart inside black holes. But unlike every other physical thing we know, we cannot point to what it is made from. It is not built from atoms. It is not built from particles. It is not built from anything we can directly detect. Space-time behaves like a substance, but it refuses to reveal its ingredients. This is where modern physics begins to feel uneasy, because today, science stands on two incredibly powerful pillars. One is Einstein's theory of space-time and gravity. The other is quantum theory, which describes the behavior of particles at the smallest scales. Both work perfectly in their own domains. Both predict reality with extreme accuracy, and yet they do not agree with each other. Einstein's space-time is smooth and continuous. It flows without breaks. You can divide it endlessly, and it still makes sense. Quantum theory, on the other hand, says that everything in nature is grainy. Energy comes in packets, light comes in particles, forces come in discrete jumps. So here is the problem. If everything else in the universe is made of tiny packets, why would space-time be infinite and smooth? This question has no answer yet. Some physicists believe space-time is truly continuous. Others believe it is made of unimaginably tiny building blocks, smaller than anything we can currently measure. These blocks would be so small that even the strongest microscopes we could ever build would never see them directly. They would be smaller than protons, smaller than quarks, smaller than anything with size. This smallest possible scale is known as the Planck scale. At this scale, the universe becomes strange beyond description. Time itself may no longer flow smoothly. Space may no longer behave like space. Cause and effect may blur. Below this scale, our laws of physics break. That means space-time, as we understand it, may be only a large-scale illusion. Smooth at big sizes, rough and grainy at the deepest level. Just like water. From far away, water looks smooth and calm. From close up, it is made of countless molecules crashing into each other. The smooth surface is just an illusion created by massive numbers. Space-time may work the same way. At large scales, it looks like a smooth fabric. At the smallest scales, it may be something violent, broken, restless, and chaotic. But unlike water, we do not know what the molecules of space-time would be. Now comes the next uncomfortable idea. Some scientists suspect that space-time may not be fundamental at all. It may be something that emerges, just like temperature emerges from moving molecules. Temperature is not a real object. It is the result of motion. In the same way, space-time might be the result of something deeper that we have not yet discovered. This means space-time itself may be a byproduct, not the foundation of reality, but a shadow of a deeper structure. If that is true, then everything we see, including stars, galaxies, time, gravity, and motion, would be surface effects of a deeper, invisible reality. We would be living inside the reflection of something we cannot see. Now think about how strange that is. We already live inside space-time. Now space-time itself might live inside something else. This creates a wall in human understanding, because our minds live inside time and space. Every thought we have is built from before and after, near and far. If space-time is not fundamental, then the true nature of reality may exist in a form that our minds are not even designed to imagine. Now consider another disturbing idea: information. Some physicists suspect that space-time may be built from information itself. Not matter, not energy, but information. The yes and no, the 0 and 1, the simple building blocks of reality. If this is true, then the universe is not just physical, it is also computational. Reality would behave like a deep cosmic code. Space-time would be the screen. Matter would be the pixels. Time would be the refresh rate. This sounds like science fiction, but parts of physics already point in this direction. Black holes, for example, behave like cosmic hard drives. They seem to store information on their surfaces, not inside their volume. This leads to the strange idea that the universe may be like a hologram, a three-dimensional world projected from information stored on a distant boundary. If space-time is a hologram, then space itself is not truly space. It is a projection of something encoded elsewhere. That means distance might be an illusion. That means location might be an illusion. That means the universe you see might be a kind of image, created from deeper, invisible rules. And yet, even this is only a guess. We have no direct proof. Now return to black holes, because they are the places where space-time is pushed to its breaking point. Inside a black hole, matter is crushed to unimaginable density. Space-time bends infinitely. Time slows to nothing. Distance disappears. The known laws of physics collapse. This tells us one thing with certainty. Space-time cannot be the final layer of reality, because it breaks. And when something breaks, it reveals that it is not fundamental. Something deeper must exist underneath it. Now think about the beginning of the universe. At the Big Bang, space-time itself seems to have come into existence, not inside something, but as part of everything. There was no before the Big Bang in our equations. Time itself begins there. This creates a question that hurts the brain. How can something begin if time does not exist yet? Beginning itself requires time, and yet time itself seems to have begun. This is not a paradox we have solved. It is a wound in our understanding. Now ask this quietly. If space-time began, what caused it? If something caused it, that cause could not have existed inside space-time, because space-time did not exist yet. So whatever created space-time would have to exist outside space and time. That sentence alone shows how far beyond human intuition this mystery goes. Now step back. You live inside something that bends, stretches, ripples, traps light, slows clocks, stores gravity, and may not even be fundamental. You depend on it every second, and yet you cannot touch it. You cannot see it. You cannot hold it. You only see its effects. This is why space-time is one of the deepest mysteries in all of science. We are trapped inside it while trying to understand what it is made of. We are like characters inside a story, trying to analyze the paper of the book while still being printed on it. Now consider this final thought for this part. Every theory we have about space-time is built using space-time. Every experiment happens inside it. Every measurement depends on it. That means space-time is both the object we study and the tool we use to study it. This makes the problem almost impossible. It is like trying to measure your own shadow while standing in total darkness. And yet science continues, slowly, carefully, with uncertainty. Now the next step becomes unavoidable. If space-time can bend, if space-time can ripple, if space-time can be crushed into black holes, if space-time may be made of deeper building blocks, then one last terrifying question remains. Can space-time tear? Now we step into the place where space-time does not just bend, but breaks. Black holes are not just strange objects in space. They are the ultimate stress test of reality itself. Every law we trust is pushed to its extreme here. Every idea we feel safe with begins to fall apart. A black hole is born when a massive star runs out of fuel. The star has spent its life balancing two forces. One force pushes outward as energy from nuclear fire. The other pulls inward as gravity. For millions or billions of years, these forces stay in balance. But when the fire dies, gravity wins instantly. The star collapses. Its entire mass falls inward at once. Matter is crushed tighter and tighter until space-time itself caves in. What forms is not just a heavy object. It is a region where space-time bends so deeply that nothing inside it can ever return. Not light, not time, not information. The boundary of this region is called the event horizon. Once anything crosses this invisible edge, it is lost forever to the outside universe. No signal can escape, no message can be sent back. The future of that object ends from our point of view. Now imagine what that really means. Light moves at the fastest speed possible. Nothing can outrun it. And yet inside a black hole, even light cannot climb back out. That tells us that space-time itself is falling inward faster than light can escape. The fabric of reality is collapsing. This is not force. This is geometry turned into a trap. Now imagine watching someone fall into a black hole from a safe distance. You would never actually see them cross the event horizon. As they fall closer and closer, their time slows more and more, relative to yours. Their movements become slower. Their body seems to freeze in place. Their image fades and reddens as time stretches without end. From your view, they never enter, but from their own view, they cross the horizon quickly and continue toward the center. Two people agree on the same event, but experience it in completely different ways. This is space-time tearing logic apart in real time. Now think about the center. At the heart of every black hole is something called a singularity. This is a point where density becomes infinite. Space-time curvature becomes infinite. Time and space lose all meaning. Our equations explode into nonsense. They divide by zero. They return infinity. They stop making physical sense. A singularity is not a place. It is a limit of understanding. It marks where space-time, as a concept, no longer works. And this is terrifying, because it means space-time is not the final layer of reality. If space-time were final, it would never break, but it does. Now remember the Big Bang. At the beginning of the universe, space-time was also crushed into an infinite density. The universe itself began as a singularity. The first moment of time is also a breaking point. The start of everything and the heart of a black hole share the same mathematical failure. This tells us something important. The birth of the universe and the death inside a black hole are connected by the same kind of mystery. Both push space-time past its limits. Both demand a deeper explanation. Now imagine falling into a black hole without fear or pain. As you approach, time outside speeds up wildly. You would see the entire future of the universe unfold in fast motion. Stars would age, galaxies would collide, everything would rush forward while your own time slowed. At the horizon, time for the outside world becomes infinite. The universe ends while you're still falling. Inside, distances twist. Directions lose meaning. Forward becomes inward. You cannot avoid the center any more than you can avoid tomorrow. The singularity is not a location you travel toward. It is a moment in your future. This is how deeply space-time breaks inside black holes. Now something even stranger appears. Black holes grow. They eat stars. They eat gas. They eat entire solar systems. At the centers of almost all galaxies, including our own, sit supermassive black holes. These monsters weigh millions or even billions of times more than the Sun. They control the motion of entire galaxies. They feed quietly for billions of years. And yet, these monsters are not destruction machines alone. They shape the universe. The energy from material falling into them regulates star formation. They balance galaxies. They drive enormous jets of radiation across intergalactic space. Without black holes, galaxies may not survive at all. Space-time breaks reality, then reshapes it. Now return to the question that began this part. Can space-time tear? Inside black holes, it does more than tear. It collapses. It pinches off paths. It closes futures. It erases directions. This means space-time is not invincible. It has limits. And wherever something has limits, something deeper must exist below it. Now think about gravitational waves again. When black holes collide, they do not just smash matter. They shake space-time itself. Ripples spread across the universe. Space stretches and compresses. Time speeds up and slows down. Every object is gently shaken by disturbances born billions of light years away. This means space-time is elastic. It can be stretched, it can be squeezed, it can be shaken, it can be torn. It behaves like a real substance, yet we still cannot touch it. We only infer its motion by watching what it does to light and matter. Now comes the most frightening idea of this chapter. If space-time can be crushed into singularities, then it can also be destroyed. Not locally, but completely. Some theories suggest that under extreme conditions, space-time could undergo phase changes. Just as water turns into steam, space-time might change into a different state of existence. Wall boundaries of reality could melt. Dimensions could rearrange. The rules could rewrite themselves. We do not know if this ever happens, but our equations allow it, and that is enough to make physicists uneasy. Now step back emotionally. Everything you see, every sky, every star, every memory, every second of your life, exists inside something that can collapse into nothing. This does not mean space-time is fragile in daily life. It is incredibly stable on human scales. But on cosmic scales, under extreme mass and energy, its calm surface hides the ability to destroy itself. This is not comforting. This is humbling. Now ask the quiet question: if space-time can break, what is left behind when it does? Does something remain, or does reality truly end? We do not know. Some theories suggest new universes may be born inside black holes. Others suggest time simply ends. Others say reality continues in forms we cannot describe. No experiment can test this yet. The horizon blocks all proof. Now think about this carefully. A black hole is not just an object in space. It is a wall in knowledge. It marks where observation dies. It marks where space-time ends. It marks where physics becomes guesswork. And black holes are everywhere. The universe is filled with holes in understanding. Now the final thought of this part appears. Space-time can bend. Space-time can ripple. Space-time can slow time. Space-time can trap light. Space-time can crush itself into nothing. And yet, we still do not know what it is made of. We are watching a powerful machine in action, without knowing what its parts are. Now the question becomes unavoidable. If space-time can tear, if space-time can collapse, if space-time can hide futures behind horizons, then is space-time truly the base of reality, or is it only the surface of something far deeper? That is where the next part will take us. Now space-time meets its greatest rival, the tiny world of particles, the strange rules of the quantum world. Until now, space-time has felt grand, smooth, and continuous. But when we go small enough, when we go deeper than atoms, deeper than protons, deeper than even the smallest known particles, space-time begins to lose its calm shape. At the quantum level, the universe is not smooth at all. It is restless, uncertain, jumpy. Particles appear and vanish. Energy flickers into existence and disappears again. Nothing stays perfectly still. Nothing has an exact position. Everything is described by probability instead of certainty. And here is the problem. Einstein's spacetime is smooth and continuous. Quantum reality is grainy and uncertain. They do not fit together. Every machine you use today depends on quantum physics. Every satellite depends on spacetime physics. Both are correct. Both work perfectly in their own worlds. But when you try to combine them into a single picture of reality, the math breaks. The answers explode into infinity. The universe stops making sense. This is the deepest crack in modern science. At large scales, space-time rules. At small scales, quantum laws rule. But the universe is one thing. It cannot follow two incompatible rule books at the same time. And yet, it seems to do exactly that. Now imagine shrinking yourself smaller and smaller. You pass through skin, through cells, through molecules, through atoms. Atoms are mostly empty space, tiny nuclei surrounded by ghostly clouds of electrons. You move through that emptiness and go deeper. You reach the nucleus, protons and neutrons packed tightly together. You go deeper still. You reach quarks, the deepest particles we currently know. At this scale, space does not feel like space anymore. You cannot point to empty locations. You cannot trace smooth paths. You cannot even say where something truly is. Everything becomes uncertain. Now here is the strange conflict. Einstein says space-time tells matter how to move. Quantum theory says matter does not always have a clear path at all. Einstein says cause comes before effect. Quantum theory allows uncertainty at the deepest level. Einstein says space-time is smooth. Quantum theory suggests reality is pixelated. Both theories are right, but together they are wrong. Now think about gravity again. Gravity is space-time bending, but quantum physics describes gravity as if it should be carried by particles, just like light is carried by photons. The particle of gravity is called the graviton, but we have never seen one. No experiment has ever directly detected it. This is strange. Every other force has a particle. Light has photons. The nuclear forces have their own carriers. Electricity and magnetism come from quantum particles, but gravity refuses to behave like them. It acts as geometry instead. Space-time bends, objects slide through that bend, no particle required. This makes gravity the odd one out, and that odd behavior may be the clue that space-time itself is not built in the same way as everything else. Now look at black holes again through this new lens. At the edge of a black hole, space-time bends so strongly that even light cannot escape. Quantum theory says particles still flicker in and out there. Energy still vibrates. But space-time says nothing can escape beyond the horizon. These two rules directly conflict. One says things must escape sometimes. The other says nothing ever escapes. Both cannot be true in the same place. This conflict creates one of the greatest puzzles in all of physics, the information problem. If something falls into a black hole, quantum theory says its information must never be destroyed. Information is sacred, it cannot disappear. But space-time says that once something crosses the horizon, it is gone forever. So where does the information go? Is it erased? Is it hidden on the surface? Is it encoded into space-time itself? We do not know. This question tells us that space-time and quantum reality do not understand each other yet. Now come the attempts to unite them. Some scientists think space-time is made of tiny vibrating strings. These strings would be the true building blocks of reality. Different vibrations would create different particles. Gravity itself would emerge naturally from these vibrations. Space-time would not be fundamental, it would be a result of string motion. Others think space-time is built from loops, tiny closed networks of quantum geometry. These loops would link together to form the fabric of space and the ticking of time. Space itself would be made of discrete pieces. You could not divide it forever. Others believe space-time emerges from pure information, not from matter, not from energy, but from abstract relationships between quantum states. Space would be a shadow of deeper mathematical connections. All these ideas are bold. All of them are beautiful. None of them are proven. Now think about how strange that is. We can detect black holes billions of light years away. We can measure vibrations in space-time itself. We can see the birth of galaxies, and yet we cannot say what space-time is made of. We cannot say if it is smooth or grainy. We cannot say if it is fundamental or emergent. We cannot say if it is physical or informational. We live inside the thing we least understand. Now consider this thought. Maybe space-time is not the stage of reality at all. Maybe it is a movie screen. And what we see as stars, galaxies, motion and time are only images projected from something deeper. A reality that has no distance, no duration, no location as we know them. If that is true, then space is not truly space. Time is not truly time. They are interpretations created by our minds inside this projection. This idea sounds dangerous, because if space-time is not fundamental, then everything you think of as solid is built on something that may not even have length or time at all. Now step back emotionally. You walk through rooms. You wait for tomorrow. You remember yesterday. You count minutes. You measure distances. All of this depends on space-time behaving in a reliable way, and it does, on human scales. But at the deepest level, reality may not have rooms, paths, or clocks at all. Those may be large-scale illusions that feel real only because billions of tiny quantum events average out smoothly. Just like water feels smooth even though it is made of chaotic molecules, space-time may feel smooth even though it is made of chaotic quantum geometry. Now comes the hardest truth of this part. Einstein gave us space-time. Quantum science gave us the rules of the small, but no theory yet explains both at once. We are standing between two perfect maps that do not overlap. One rules the large, one rules the small, and the bridge between them is missing. That missing bridge is the greatest unfinished story in science. Now the final question of this part rises naturally. If space-time breaks at the quantum level, if gravity refuses to behave like other forces, if black holes destroy logic, then is space-time truly real at all? Or is it only a powerful illusion created by something deeper? That question leads us directly into the next part, because the next part is where space-time may lose its title as the foundation of reality itself. Now the story of space-time takes its strangest turn. Until now, space-time felt like the solid stage of reality, the thing everything lives inside, the thing nothing can escape. But what if space-time itself is not the stage at all? What if it is only the image on the stage? This idea sounds impossible at first. How can space not be space? How can time not be time? How can the thing that holds everything fail to be real in the deepest way? And yet modern physics keeps pointing in that strange direction. One of the most shocking ideas ever proposed is that space-time may be a projection. Not in the movie sense, not in a fake sense, but in a deeper physical sense. The universe may work like a hologram. In a hologram, a flat surface can store all the information needed to create a three-dimensional image. The depth you see is not truly there. It is created from hidden data. Some physicists now believe the universe may work in the same way. All the three-dimensional space you move through, all the depth you feel, all the distance between stars, may be encoded on a distant two-dimensional boundary. If this is true, then space is not fundamental. It is emergent. It appears when information is organized in the right way. This is not speculation without reason. Black holes forced this idea into science. Black holes taught us that information is not stored inside a volume the way we expected. It appears to be stored on surfaces. The amount of information inside a black hole depends not on its volume, but on the size of its surface. This was completely unexpected. It suggested that nature cares more about boundaries than about interiors. This strange rule did not stay inside black holes. It began to appear everywhere. It began to look like the universe itself might store its information on a cosmic boundary, and the space inside might simply emerge from that information. If that is true, then space-time is not the foundation of reality. It is the shadow cast by deeper information. Distance would not be a basic feature of the universe. It would be a result of how information is connected. Time would not be fundamental. It would be a result of how information changes. Space and time would not be the roots. They would be the branches. Now feel how deeply this changes everything. The universe would no longer be a place filled with objects. It would be a process. It would be a calculation unfolding. It would be information reorganizing itself. Now remember something important. When information changes, time seems to pass. When information is stable, time feels frozen. This suggests that time may be nothing more than the flow of information itself. In this view, time does not cause change. Change creates time. And space-time becomes the record of how information connects and transforms. Now let this idea sink in slowly. If space-time is made of information, then when you move through space, you're not traveling through a substance. You are moving through changing relationships between bits of reality. Location becomes a pattern. Motion becomes a transformation of connections. Near massive objects, these connections tighten. Time slows, space compresses, not because of force, but because the information network is changing its structure. This would explain why gravity looks like geometry instead of force. Because geometry would be nothing more than the shape of information itself. Now something incredible appears. If space-time is made of information, then it is not continuous. Information is always discrete. It comes in bits, yes or no, on or off. That means space itself may be pixelated at the deepest level. Time itself may advance in tiny steps. The smooth space-time we experience would be like a high-resolution screen. It looks smooth only because its pixels are too small to see. Now return to quantum entanglement. Two particles can be connected instantly, no matter how far apart they are. Distance does not weaken this connection. This breaks the usual idea that space separates things. But if space itself is built from information connections, then entanglement is not strange at all. The connection comes first. Distance comes later. In that case, space-time is not what creates relationships. Relationships create space-time. Now that idea is radical. It means the universe is not built from objects placed in space. It is built from relationships that create space. This reverses everything we thought we understood. Now think again about black holes in this new light. If space-time is just an emergent structure, then when it collapses inside a black hole, reality itself is not ending. The underlying information could still exist in another form. The horizon would simply be where space-time as we know it stops being the right language. The singularity would not be a point of destruction. It would be a point where space-time no longer applies. Now think again about the Big Bang. Maybe space-time did not truly begin at the Big Bang. Maybe something deeper existed first. A sea of information. A network of quantum connections. And what we call space-time simply emerged from that deeper layer as the universe cooled and expanded. In that case, asking what happened before the Big Bang may be the wrong question, because time itself would emerge after. There would be no before in the way we imagine it. Now the universe stops feeling like a place. It starts feeling like a process, a perpetual unfolding of relationships. Now step back emotionally. You feel like you live inside space. You feel like you move through time. But at the deepest level, you may live inside information itself. Your body would be a stable pattern in that information. Your thoughts would be changing patterns in that information. Your memories would be stored patterns in that information. Space-time would simply be how those patterns feel from the inside. Now look at how strange this becomes. If space-time emerges from information, then the universe is not located anywhere. There is no outside. There is no background. There is only structure and change. The idea of location becomes secondary. Reality is not happening in space-time. Space-time is happening in reality. This flips the entire story of existence upside down. Now consider the most dangerous implication. If space-time is emergent, then it can possibly emerge in more than one way. That means other universes may exist that do not share our space or time. They would not be far away. They would be separate at the level below distance itself. You would not reach them by travel. You would reach them by different rules. Now pause and feel the weight of this. Until now, we imagine the universe as one giant place. Now it may be one outcome in a larger landscape of possibilities, each with its own space-time, each with its own laws, each with its own version of distance and time. If this is true, then space-time is not just a mystery, it is one variant among many. Now the emotional meaning deepens. Everything that makes your life feel real depends on space-time behaving in a certain very special way. If its rules were slightly different, stars might not form, atoms might not last, chemistry might fail, life might never appear. Space-time is not only strange, it is finely balanced. Now the quiet question rises, again. If space-time is not fundamental, if it emerges from information, if it can collapse inside black holes, if it may have emerged at the birth of the universe, then what truly is the foundation of reality? We have moved past space, we have moved past time, we have moved past matter, and we are now approaching the deepest mystery of all. What is underneath everything? That is where the next part will take us. Now we come to the strangest idea of all. The idea that time itself may not be what it feels like. You feel time moving. You feel moments pass. You feel the past fall away and the future move closer. It feels obvious. It feels real. And yet space-time suggests something much more unsettling. In Einstein's universe, time is not a single river flowing the same way for everyone. Time bends, time slows, time speeds up. Time depends on motion and gravity. Two people can experience the same event and disagree on how long it lasted. Two clocks can tick at different speeds and both be correct. This means time is not universal. There is no single now that belongs to the entire universe. Your present is not the same as someone else's present if they're moving differently or living in stronger gravity. What feels like the same moment to you may already be in the past or future for someone far away. This alone breaks the idea of one shared reality. Now comes the more disturbing idea. If time depends on motion and gravity, then time is not a separate thing. It is woven into space-time, and space-time is already a structure that exists all at once. In that picture, the universe is not a movie that is being played frame by frame. It is more like a complete map. Every moment already exists as a location in space-time. The past is not gone. The future is not waiting. They are both already part of the structure. Your life is not a story being written. It is a path already drawn. You are simply moving along it. This is called the block universe idea. In this view, the universe does not change. Everything that ever happens already exists in space-time. Birth, death, childhood, old age, tomorrow, next year, distant futures, all of them already exist as different regions of space-time. You do not create the future, you travel through it. This idea feels dangerous because it attacks free will. It attacks choice. It attacks the feeling that tomorrow is open. But space-time does not care about how things feel. It only describes how things are structured. Now think about this carefully. If the future already exists, does that mean you cannot change it? Or does it mean that your choices are already part of the structure? Your decision to turn left instead of right would not be something that creates a new future. It would already be a feature of the space-time path you follow. This is not easy to accept. But space-time allows it. Now something even stranger appears. If all moments already exist, then time does not truly flow. The feeling of flow may come from how your brain moves through space-time. Consciousness may be sliding along a fixed path, experiencing one slice at a time. The universe may be frozen. Only awareness moves. Now think about memory. You only remember the past. You never remember the future. This creates the feeling that time moves forward. But space-time allows memory to be one-directional, even if the structure itself is not moving. You feel time because your brain stores information in only one direction along your path. The arrow of time may not come from space-time itself. It may come from how memory works. Now think about the laws of physics at the deepest level. Most of them do not care about past or future. They work the same forward or backward in time. If you reversed all particle motions, the equations would still work. The universe's basic rules do not prefer yesterday over tomorrow. So where does the feeling of forward time come from? It comes from disorder, from entropy, from the fact that things tend to go from ordered states to disordered states. A tidy room becomes messy. A broken glass never jumps back together. A cold room never becomes warm without energy added. Disorder increases. This increase is what gives time its direction. But space-time itself does not demand a direction. It simply allows one. Now think about this in daily life. You feel like the past is fixed and the future is open. Space-time suggests the past and future are equally real. The feeling of openness may be an illusion created by limited knowledge. You do not see future information stored in your brain, so the future feels unknown. But unknown does not mean non-existent. Now return to gravity again. Near a black hole, time slows so much that the future of the universe races past you while your own time barely moves. This means different parts of space-time experience the build-up of the future at wildly different rates. One observer may see 1,000 years pass while another experiences only minutes. This is not philosophy. This has been measured with clocks in space. Time is not the same thing everywhere. Now feel how deeply this breaks common sense. If time is not universal, if the present is not shared, if the future already exists, then what does now even mean? Now becomes local. Now becomes personal. Now becomes dependent on where you are and how you move. The universe does not have a single now. It only has many private nows. Now think about the far edge of the observable universe. There are regions so distant that their present can never affect our present. Light from there will never reach us. Their now and our now are permanently disconnected. This means the universe is not one synchronized moment. It is a set of overlapping but incomplete timelines. Now think about communication again. When you speak, your words move through space-time as sound waves or light waves. By the time your voice reaches someone across the room, your now is already their past. Every conversation is made of tiny time travels. You never speak in the present. You always speak into the past of someone else. Space-time makes even simple communication a kind of time distortion. Now pause and feel this. You are not living at the same time as anyone else in the exact way you imagine. Everyone lives in their own slightly shifted now. Now this creates a final deep question. If time may not truly flow, if the past and future already exist, if space-time is a completed structure, then what is change? Change may not be the universe changing. It may be you moving. Not moving through space, moving through time. Now remember earlier parts. Space-time bends, space-time ripples, space-time stores gravity. Space-time may be made of information. Space-time may be emergent. Space-time may be a projection. And now, space-time may already contain every moment that will ever happen. This is not small mystery. This is the deepest shock space-time delivers. It does not just change how we think about gravity, it changes how we think about existence itself. Now the next question becomes dangerously personal. If the future already exists in space-time, then does death also already exist as a location? Is the end of every path already part of the structure? Space-time suggests yes, and that makes life feel both fragile and strangely permanent at the same time. Your life would be a path carved into space-time forever, not erased, not undone, always part of the universe's structure. Now the final thought of this part emerges. Time may not be a river, it may be a landscape. You are not floating forward, you are walking across it, and you can only see one step at a time. The deeper we go into space-time, the more it dissolves the ideas that once felt certain. And the next idea it will challenge is the most dangerous one yet, the idea of cause and effect itself. For most of your life, one rule has always felt unbreakable. The past causes the present causes the future. A stone is thrown, then the glass breaks. You touch fire, then you feel pain. Cause first, effect second. This feels so obvious that it feels like a law beyond all laws. But space-time quietly disagrees. At the deepest level, the universe does not clearly separate cause and effect the way your mind does. In everyday life, they appear clean and orderly because space-time is calm and slow around you. But when space-time bends strongly, when motion becomes extreme, when gravity grows intense, this neat order begins to blur. In Einstein's universe, what one person calls cause can appear as effect to another person who is moving differently. Two observers can disagree on which event happened first and both be correct. Not because they are confused, but because space-time itself allows different time orders. This is not philosophy. This has been tested with real particles in real experiments. At very high speeds, the order of events can flip depending on how you move. The universe does not protect a single universal sequence of before and after. Cause and effect are local, not absolute. Now go deeper. Quantum physics adds even more discomfort. At the smallest scales, events do not always happen with certainty. A particle can choose between multiple possible futures. You only see the outcome when you observe it. Until that moment, reality is not decided. This already weakens classical cause and effect, but space-time pushes it even further. In some quantum experiments, the result seems to reach backward in time. A choice made in the present appears to influence how a particle behaved in the past. This does not mean we can send messages to yesterday, but it does mean that the boundary between past and future is not as solid as it feels. Space-time does not promise that the past is completely locked. It only promises that you cannot change what you already remember. Now return to black holes. At the edge of a black hole, cause and effect stretch to their limit. To someone far away, an object never truly crosses the horizon. It slows forever. To the falling object, it crosses quickly and continues onward. Two observers see two completely different versions of the same event. One says, "It never happened." The other says, "It already happened." Both are correct inside their own space-time paths. So did the object fall in or not? Space-time allows both answers to be true. Now think about the beginning of the universe again. The Big Bang is usually described as the ultimate cause, the first event, the start of everything. But space-time itself begins there. There is no earlier moment inside space-time. That means the Big Bang has no cause inside time. It simply exists at the edge of all cause and effect. This breaks the most basic idea the human mind depends on, that everything must have a cause before it. Space-time suggests that before itself may not always exist. Now think about relativity again in daily life. Your present moment is not shared by the entire universe. Someone far away cannot agree on what now means for you. Because of this, the chain of cause and effect becomes stretched across space-time, not locked into a single universal order. An event that is in your future may already be in the past for someone moving differently. This sounds impossible. But space-time allows it. Now let this sink in. The universe does not run on a single clock. It runs on countless overlapping clocks, and cause and effect flow along each of them differently. Now return to quantum entanglement. Two particles can be connected so deeply that measuring one instantly changes the behavior of the other, no matter how far apart they are. Space-time says nothing can travel faster than light, and yet something about the state of one particle is immediately linked to the other. This does not allow faster-than-light messages, but it does show that space-time distance does not fully separate reality. Connection can ignore distance in ways that classical cause and effect cannot explain. This raises a dangerous thought. Maybe cause and effect are not truly carried through space-time at all. Maybe they come from a deeper level underneath space-time. Now think about time travel. Space-time does not completely forbid it. According to Einstein's equations, certain extreme conditions could allow paths that loop back in time. These paths are called closed time-like curves. They are allowed by the math, even if we do not know how to build them in reality. If such paths exist, then cause and effect could form loops. An event could be both cause and effect of itself. This is the ultimate break in logic. A future event could be the reason for a past event. Space-time does not promise that this cannot happen. It only makes it extremely difficult. Now remember earlier when we said space-time might be emergent from information. If that is true, then cause and effect may also be emergent. They may not be fundamental rules of existence. They may only be patterns that arise when information flows in a certain stable way. In other words, the universe may not truly run on causes and effects. It may run on consistency. Reality may simply settle into patterns that do not contradict themselves. What we call cause and effect could be how our minds interpret those stable patterns. This would explain why time seems to move forward, not because the universe demands it, but because stable patterns only survive in one direction. Now think about your own life again. You feel like your past created your present, and your present will create your future. This is how memory works. You remember what already happened. You do not remember what has not happened yet. This gives the brain a natural direction. But space-time itself may not care which way you call forward. It simply contains the whole structure. Your sense of direction is built from memory, not from the deepest rules of reality. Now stand at the edge of this idea. If cause and effect are not absolute, if time does not truly flow, if the future may already exist, then what does it even mean to make something happen? Your daily experience still feels real. You still choose, you still act, you still change things around you. Space-time does not take that away, but it changes what change means. Change may not be the universe being rewritten. It may be the universe being revealed one slice at a time to a moving observer. Now think about fear and hope. Fear comes from imagining bad future outcomes. Hope comes from imagining good ones. Both depend on believing the future is open. Space-time does not clearly promise that openness, but it does allow uncertainty from your point of view. And that uncertainty is enough to give meaning to choice, because even if the path exists, you still experience it as undecided. Now one final strange idea appears. In some interpretations of quantum physics, every possible outcome actually happens. The universe splits into many branches. In one branch you choose left, in another you choose right. All possibilities exist at once inside a larger structure. If space-time truly contains all moments, then it may also contain many versions of them. This is too strange to prove, but space-time allows it. Now pause and feel how far the idea of space-time has taken us. It began as geometry. It became gravity. Then it became vibration. Then it became information. Then it became a landscape of all time. Now it is threatening the very idea of cause itself. And we are still not done. Because the final challenge of space-time does not come from black holes or time travel. It comes from the simplest question of all. Why does anything exist at all? And if space-time is not fundamental, then existence itself must rest on something even deeper. That is where the next part will take us. Now we stand at the edge of the final mystery. Up to this point, space-time has been stretched, bent, rippled, broken, questioned, and possibly demoted from being the foundation of reality. We have seen that it may be built from information, that time may not truly flow, that cause and effect may not be absolute, that even space itself could be an illusion created by deeper connections. So now the question becomes unavoidable. If space-time is not the deepest layer of existence, then what is? Everything you experience is filtered through space-time. You see using light that travels through it. You move using distances defined by it. You remember using time shaped by it. Even your thoughts unfold inside it. If space-time is not fundamental, then your entire sense of reality is built on top of something you cannot feel directly. That something may not look like space. It may not feel like time. It may not behave like matter. It may be something far stranger. Some physicists suspect that the deepest layer of reality is not made of things at all, but of relationships, not particles, not waves, but pure connections between abstract states. In this view, nothing exists by itself. Things exist only because they are related to other things. Space is just how those relationships appear to us as distance. Time is just how those relationships appear as change. If this is true, then the universe is not a collection of objects. It is a network, a web of relations that never sit still. Now think about how different this is from the way reality feels to you. You feel like you're a thing inside a space. You feel like you move through time. You feel like objects exist on their own. But at the deepest level, your body may be nothing more than a stable pattern in a sea of relationships. Your identity may be a repeating structure of information, not a solid object moving through empty space. In this view, space-time is not where things happen. Space-time is how relationships feel from the inside. Now consider this idea carefully. If space-time emerges from relationships, then when relationships change, space-time changes. This would explain why gravity bends space-time. Mass would not be curving space directly. It would be changing the structure of relationships so deeply that space itself is reshaped as a result. If space-time emerges from relationships, then quantum entanglement makes sense. Two particles remain connected because at the deepest level, they are still part of the same relationship structure, no matter how far apart they appear in space. Distance would be a surface effect. Connection would be the deeper truth. Now look back at everything that has confused us so far. Time slowing near black holes, future and past losing their strict order, events disagreeing about cause and effect, space-time rippling as waves, black holes destroying information in space-time but not at the deeper level. All of these strange effects point to the same conclusion. Space-time is not the bedrock of reality. It is a behaviour that reality shows. Now think about the moment before the Big Bang again. If space-time emerged with the universe, then before it emerged, there was no space and no time. But that does not mean there was nothing. It only means there was no where and no when as we understand them. Something had to exist in a form beyond location and beyond duration. That something may be the true foundation of existence, and we do not yet have language for it. Now think about the most basic question of all. Why does anything exist instead of nothing? This question sounds simple. It is not. Space-time cannot answer it. Energy cannot answer it. Matter cannot answer it. Because all of these things already assume existence. To explain existence itself, you must go deeper than all physical concepts we currently have. Space-time was our best attempt at a foundation, and now even space-time is under question. Now the universe begins to feel less like a place and more like a logical fact, something that simply is without needing a cause in time, because time itself may be a result of it. This is where science and philosophy quietly meet again. Not because science has failed, but because it has gone so deep that its questions are no longer about motion, force, or energy. They are about being. Now think about what this means for you. You are not just a traveller through space-time. You may be a pattern inside the deepest level of reality. Your birth would not just be something that happened at a time and place. It would be the appearance of a new pattern in the structure of existence itself. Your death would not just be the end of motion. It would be the dissolving of that pattern back into the deeper field. Space-time would only describe how that pattern appears to itself. Now, this idea is not proven, it is not confirmed, it is not settled science, but it is where the hardest questions now point. And no easier explanation has survived. Now return one last time to space-time itself. We once thought space was empty and time was universal. Then we learned space bends and time slows. Then we learned space-time ripples and traps light. Then we learned it may be built from information. Then we learned it may not even be fundamental. At every step, reality became less solid, not more. This is the hidden pattern of human knowledge. The deeper we go, the less concrete things become. At the surface, the world feels solid. At the deepest level, the world becomes abstract. And yet, both levels are real. Now the final question of this part rises gently. If space-time is not the deepest truth, if existence rests on something beyond space and time, then will we ever truly understand the universe? Or are we built to only see its shadows? We may never know. But the fact that we can even ask this question on a small planet inside a vast universe is already something astonishing. And now, only one final piece remains. What does all this mean for how we live? That is where the last part takes us. Now we return to where we began, not to equations, not to black holes, not to the edge of time. We return to you, sitting quietly on a small planet inside a universe that does not explain itself easily. After everything we have seen, space-time no longer feels like a simple stage. It bends, it ripples, it slows time, it traps light. It may dissolve into information. It may not even be fundamental. It may be only the surface of something far deeper that we do not yet understand. And yet, even with all this uncertainty, your life still unfolds inside it. You still wake up in the morning. You still wait for tomorrow. You still remember yesterday. You still move through rooms. You still feel distance and duration. Space-time may be strange at the deepest level, but it still holds your daily reality together. This is the quiet miracle. The deepest mystery in science is also the most familiar thing you live inside. Now think about this carefully. Space-time does not care about you. It does not notice your birth. It does not pause for your death. It does not bend because of your fear or your hope. And yet, your entire experience of existence is carved inside it. This creates a strange balance between smallness and meaning. You are small in size, small in time, small in influence over the universe. But inside that smallness, you experience everything that meaning has ever been. Love, loss, curiosity, wonder, memory, choice. None of these things appear in equations. None of them bend space-time. And yet, without them, the universe would be completely empty of significance. Now think again about time. Space-time suggests the future may already exist, that the past is not erased, that all moments may be part of one great structure, and yet you still experience life one moment at a time, one breath at a time, one decision at a time. You still feel uncertainty, you still feel fear, you still feel hope. Space-time may contain your entire path, but you only ever experience one step, and that is what gives life its meaning. If you could see everything at once, nothing would feel important. Meaning comes from not knowing. Now think again about cause and effect. Space-time allows strange loops. It allows time to slow and stretch. It allows different observers to disagree on what happened first. And yet, in daily life, kindness still causes kindness. Violence still causes pain. Care still causes healing. The deepest rules of space-time do not cancel the simplest rules of being human. Space-time may blur, cause at the edge of black holes. But right here, it still responds to how you treat others. Now think again about information. If space-time emerges from information, then your thoughts are not just passing feelings. They become part of that deeper structure. Every memory is a pattern that reality briefly holds. Every idea is a temporary shape in the deepest layer of existence. You are not separate from the universe looking at it from the outside. You are something the universe is doing on the inside. Now think again about black holes. They crush space-time. They erase paths. They hide futures behind horizons. And yet, even they may not destroy information at the deepest level. Meaning may survive in forms we do not yet understand. This tells us something quiet and powerful. Even when space-time breaks, reality may not end. Now stand back and look at the full journey. We began with space and time as simple ideas. We watched them merge into space-time. We watched space-time bend into gravity. We watched it ripple as waves. We watched it collapse inside black holes. We watched it clash with quantum reality. We watched it dissolve into information. We watched time lose its flow. We watched cause and effect blur. We watched existence press against something deeper than space-time itself. And at the end of all that, one thing remains unchanged. You are still here, breathing, wondering, asking questions. That alone is astonishing. Now comes the final truth of this entire series. We may never fully understand space-time. We may never know what it is truly made of. We may never know what existed before it. We may never know what lies beneath it. But we already know what it allows. It allows stars to shine. It allows planets to form. It allows life to appear. It allows minds to awaken. And it allows the universe for a brief moment and in one small corner to be understood from the inside. Now think about how rare that may be. Out of all the space, out of all the time, out of all the galaxies, a small world learned to ask what space-time is. That may be one of the rarest events in the universe. Now the meaning becomes clear. Space-time may be strange. It may be bending and rippling beneath your feet. It may be made of information. It may hide deeper layers of reality. But it still gives you a place to stand, a moment to exist, a chance to ask why. Now the final thought arrives, quietly. You do not need to understand space-time to live inside it. You only need to be aware that you do, that you are part of something unimaginably large, that your life unfolds inside a mystery that has no simple explanation, and that mystery, instead of making life smaller, makes it deeper, because every moment you experience exists at the meeting point of the known and the unknown, between what science can prove and what the universe still keeps hidden. Spacetime is the stage of all questions, and for now, being able to ask them may be the most important answer we have. Space-time bends, ripples, and hides its deepest secrets from us. We may never fully understand what it truly is. But every second we live, every step we take, every memory we keep happens inside it. We do not just live in space-time, we are part of its story.